Imagine you are a flood risk manager for the city of New Orleans. You get an alert from the National Weather Service that flooding is possible. You look at the radar, you have seen this type of storm before. New Orleans has an online platform, streetwise.noaa.gov, that lets citizens upload data about which neighborhoods are flooding during storm events. You recommend that the city issues text alerts, let people park on the neutral ground, and release sandbags for the potentially affected areas. This is how we currently manage storm and flood events. We use historical, user-generated data to see how known storm events cause flooding. New Orleans has used this data to update the EPA's Stormwater Management Model or SWIM software. Here, you can see a model that the Sewage and Water Board released in July of 2019 based on a single storm event. Areas in red are at a higher risk for flooding than the areas in blue that are at a lower risk. This system works, but there is uncertainty in the data. Here, you can see known flooding location in red and rain gauges in yellow. The report that the Sewage and Water Board released admitted that there could have been additional flooding locations that did not have published photos available. The issues with using published photos for detecting the flood locations include missing data and having to estimate rather than measure the flood water level. Again, the current process introduces uncertainty. The vision for this project is to reduce the uncertainty in flood water measurement. We are creating a system that will give flood risk manager real-time insight into which neighborhoods will flood and when during a storm event. As well, the system will inform the EPA's SWIM software with more accurate timestamp data that is then used for future predictive simulations.
There are two parts of this system, the sensor node and the cloud. The sensor nodes will be deployed underneath street manholes, bridges, and overpasses in areas prone to flooding during severe rainfall events. The sensor nodes capture the water level underneath the manhole or bridge and send the data to the back-end cloud server where it is stored. The collected data is processed and directed to the front end where the results are visualized and displayed on a dashboard. The stored data can be pulled into SWIM for model calibration and then analyzed to identify how city officials can prioritize drainage improvements. Currently, we have one water level sensing device that you can see here with its boron cellular microcontroller, lithium-ion batteries, waterproof enclosure, ultrasonic depth sensor, and adjustable linkages. We have the parts for 5 more devices on the way. We will deploy these 6 under manholes on UNO's campus and collect data to see if we can predict when floodwaters will rise above the street. In the coming year, we will design a custom circuit board to drive down costs and to make the device easier to assemble. Additionally, we will integrate solar to extend the device's battery life. The front end of our platform is in development as well. Alongside the water level, you are able to see live radar of weather events affecting the city. In the future, we can imagine using these devices to automatically send alerts to potentially automate decision-making. Imagine the scenario in which real-time and historical data collected by the devices inform a model that accurately predicts how an incoming weather event will impact neighborhoods in New Orleans. The flood risk manager will get an alert as to how flooding will impact those specific neighborhoods and will know within a few inches what the water level will be. The official can then recommend deployment of resources such as sandbags and issue alerts only to those potentially affected areas. More broadly, this type of data collection can enable other types of automation, and we are excited to continue researching and exploring the possibilities. Thank you for watching our video. You can reach us Marat Tanil, mtanil@uno.edu, and Michael Sarasso, msarasso@uno.edu.